Hey everyone, in this video we're going to be going over factoring. So factoring is one of those things that you have seen you all know how to do with normal, just regular numbers, but when it comes to expressions, it's just a little foreign, but that doesn't necessarily make it hard. So if I asked you, before we start doing this problem, if I asked you to provide me with the factors of 18, you might tell me that we could do 6 times 3, or you could say 9 times 2, or maybe just 18 times 1. So those numbers that were being multiplied together to equal 18 are what we call factors of 18. And so what we're doing here with these expression problems is that we want to determine what two expressions do we need to multiply together to equal back to this expression. So in this first one, and the way that we do that is we look at what can we pull out, or what can we take out of 3x and 27. Well, I wouldn't say that I could take out an x because there's no x over here. If there was an x here on the 27, then we could pull out an x from both of them. But because there isn't, we have to choose some number to pull out. Well, the only number you can really pull out of 3 is 1 and 3. So that's kind of your hint that what you're going to be pulling out of 3x and 27 is going to be the number 3. And so the number that you pull out, goes into the first set of parentheses. So all your answers should be in 2 sets of parentheses. The number you pull out goes in the first set. And then to figure out what number you get into the second set, because we're doing technically what we'll do here is we'll multiply. In order to figure out what goes in that second set, you do the opposite. You divide by the number you pulled out. We're pulling out a 3, so what I'll do is I'll divide both terms by 3. 3x divided by 3, well, any number over itself is 1. We're working with that right now with inequalities. Any number over itself is 1, so that's going to just leave me with x. Plus 27 divided by 3, that's going to leave me with 9. So how do I know that these are actually factors of 3x plus 27? How do I know that 3 and then x plus 9 are factors of 3x and 27 the same way that 6 and 3 are factors of 18? I can check by multiplying. So I'm going to multiply out what I got here. I'm going to multiply 3 times x. I'm going to do into the distributive property here, and I'm going to multiply 3 times 9. 3 times x is 3x, plus 3 times 9 is 27. And I got the same expression that I started out with. So that goes to show me that yes, 3 and then x plus 9 is the factored version of 3x plus 27. Let's go ahead and try another one. Another thing that we need to talk about with these factoring problems is that you can, for 18 and 48, you can pull out more than just a 2 here. You can also pull out a 3, and you might be able to pull out some other numbers as well. So the fact that we can pull out a 3 and a 2 and a 3 also means we can pull out a 6, because 2 times 3 is 6. But what I want to do here is I want to pull out a number so that when I pull that number out, the numbers that go in a second set of parentheses are no longer able to be simplified. So what do I mean by that? If I decided to pull out a 2 from both of these, let's say I pulled out 2, then I would determine what goes on the inside of my second set by also dividing both of these by 2, which would leave me with 9c plus negative 24. But 9 and 24 can be simplified. 9 and 24 we can pull out a 3 from that. So we've already pulled out a 2, but we'd also pull out a 3, which would leave me with 3c plus negative 8. And I don't want two numbers here on the outside, so I'm going to multiply those together because this is technically 2 times 3c plus negative 8. And so this would be 6 times 3c plus negative 8. So what I did here to determine what the biggest number that I would pull out here is I multiplied the two small numbers that I pulled out, that I factored out. That 2 and that 3, I multiplied them together to get 6. And so 3c plus negative 8, there isn't anything that I can pull out of that besides the number 1, because 3 and 8 3 is a prime number and it doesn't go into 8. So that would be my simplest form of this factoring. You might have saw right away that 18 and 48, the biggest number you could factor out of both of those would be 6. That's the greatest common factor is what that's called. Greatest common factor. So if you saw that right away, then awesome. If you didn't, you can always just double check to see, are the numbers that I got, are they able to be simplified down even further? Is there something that I can factor out even further? In 9 and 24, yes, we could factor out a 3. But with 3 and 8, that is as factored out as it goes, so we would just leave it as 3c plus -8. Now, you guys get kind of confused, not you guys, but just some people get kind of confused when you see decimals. Decimals just seem kind of odd, but I just want to remind you that you can look at these decimals and think about them as whole numbers, 36 and 108. So we can pretend that they're whole numbers, and 36 and 108 are both even, so that probably means I can take out a 2 out of them. But because these are decimals, I'm not taking out just a 2, I'd be taking out a 0.2 or a 0 and 2/10. The easier thing to do with these kind of problems is that you're generally going to get a number that can be factored out by its coefficient. That's the number that's attached to the variable. So it's always good to try the coefficient first. So let's see, if we were to factor out the coefficient, 3 and 6/10, would we get a simplified version here in our second expression, our second factor? Well, 3 and 6/10 x divided by 3 and 6/10, well, that's just x, because 3 and 6/10 divided by 3 and 6/10 is just 1. Minus 10 and 8/10 divided by 3 and 6/10. Let's see what that gives us. I'm going to move the decimal over once, which moves this decimal over once. So it's 36 into 108, which goes in 4 times. 4 times 36 is 108. And so this becomes x minus 4. And 1 and 4 don't have any other number that could be factored in. If this was something like 2 and 4, then yes, we could do that. But because this is in its simplest form, that's my answer right there. And all I had to do was factor out that coefficient, that number that was attached to the x, and I saw that I'd get x minus 4 in as my second factor. So my tip for you is just go ahead and try the coefficient first. If that coefficient doesn't work, then you might need to do a little bit of reasoning to see what can you pull out. Maybe try some small numbers. But in this case, 3 and 6/10 was the number that we needed to factor out. Okay, on this one might seem a little tricky because it has 3 different variables. We got x, y, and z. But we also have the numbers 3, 6, and 9. And 3, 6, and 9 all have a greatest common factor of 3. And so if they all have a common factor of 3, then that means that's what I can pull out of this. I can make my 2 sets of parentheses, and I can pull out a 3 from all of these. So I'm going to put 3 here, and I'm going to divide each of these by 3 to determine what I'm going to put into my second set of parentheses. Well, 3x divided by 3, that's simple. That's just x. Plus 6y divided by 3. 6 divided by 3 is 2, and then the y stays. And then 9z divided by 3, that's going to be 3z. And then this now only has 1, 2, and 3. None of those numbers have a greatest common factor besides 1. The variables are all different, so I can't pull out a variable. So that would be my factored out version. So that one was actually super simple, as long as you recognize the rules for it. I don't want to make it seem like all of this is simple, but it's becomes simple when you recognize the rules for, or the algorithms for solving out these kind of problems. All right, we've got 2 left. I'm going to let you go ahead and knock out this one on your own. Just remember what I said. You want to try the coefficient first. And if that coefficient doesn't work, then maybe try reasoning through some other ones. Hint, hint, the coefficient is going to work. And on this last one, the fractions, now that we're getting a little bit more comfortable with fractions, I'm also going to give you that same hint. Try the coefficient first. What happens when we factor out a 1/8? Let's just see what we get. And how do I get what goes into my second set of parentheses? I divide by that same number that I factored out. So the first part's going to be easy because 1/8 divided by 1/8 is just going to be 1x. Minus, now I have to do 3/4 divided by 1/8. But we don't ever divide fractions. What do? We keep change flip. So it is now going to be 3/4 times 8 over 1. 3 times 8 is 24. 4 times 1 is 4. And 24 divided by 4, or 24 over 4, is 6 wholes. And so now now that I look at it, I see that I've got a very straightforward answer. When you factor out a 1/8, you get 1/8 times the quantity of x minus 6. Nice and simple. So I think what I would recommend here, the suggestion I have, is that always keep in mind that if you're going to be dividing a fraction, you're going to need to do a keep, change, flip. And then after that, it becomes super elementary because it's just multiplying numbers straight across. Then it's just 3 times 8 is 24. 4 times 1 is 4.